This is the Danelectro Series E Model 272. There's actually very little information about this amplifier to be found online, though there is information about other Danelectro models close to this one. This particular one is somewhat of an enigma. I was able to find schematics about models that somewhat resemble this model, but not this exact model. We're going to take this one apart. What this one needs is just a general service. I'm told there's nothing particularly wrong with this, but it hasn't had a service. The capacitors need to be looked at, the voltages need to be checked, and what have you. It seems to be broken up into two separate parts. There's a top element here with the controls, and there is also bottom circuitry located here. This seems to be where the power supply, the rectifier, the output circuitry all seems to be. And then it goes up to here. We'll see what we got. This particular model, the Series E Model 272, is very hard to find information for. This was made by Danelectro in Red Bank, New Jersey, probably around the early 1960s, probably 1960. We can see it separated into two parts. The metal has a very nice condition to it. Some obvious wear. The knobs look good. The potentiometers feel good. It's all going to be cleaned. You have a vibrato switch connection here. The channels have two connectors on each. I haven't understood that yet. I'm sure there's a logical reason for it. A dual pilot light. There is a fuse cap. I have it taped on. There's no fuse, so I didn't want it falling off. I have it taped on to the inside. Your power switch, toggle, dual pilot, power cord, the non-earth ground type. Very quick inspection shows. Obviously some, you see some 6v6s here. I don't know if it's single-ended. With that 6v6 output, dual 6v6s. I imagine there's a, we could see something for the vibrato, a tube for the vibrato. I haven't looked yet. I'm going to look inside. I see the audio output transformer, the power transformer. See another tube up here, hidden up here. Let's take the cover off. Let's have a look inside. So we have a 12AX7, which is shielded. In this unit, I've taken it off. We've got our complementary 6v6 GT and our output tubes. This is a 6AU6A. Its function in this amp is to be determined. And this is a 6X5. It's a rectifier tube right there. And right over here, I keep forgetting, we're going to take a look at this and see what we got here. We have got a magical mystery tube. No, this is definitely a replacement. This is a Sovtech. It's a 12A. This is a 12AX7. So there's another 12AX7. This is probably for the 12AX7 for that vibrato circuit, right? And this is going to be the 12AX7 acting in the capacity of the preamplifier for this amp, right? So preamplifier, vibrato. Okay, very good. So that's our complementary tube set. I get the sneaking suspicion that the speaker is not original. Maybe it is, I don't know. Early 1960s, having plastic quick disconnects for a speaker would seem rather strange to me. There is a manufacturer's code. That would be my Kilo 12 Charlie 290 1098 237, for those who might know what type of speaker this is. It was centered in the cabinet nicely. I mean, you know, nothing bad to say. It looks like the speaker was pre-installed in a different position in another cabinet. You could see the screw wear in the every other hole, like it was mounted in a different cabinet rotationally in a different direction. So I have every reason to believe it was installed in a different cabinet. I removed the bottom. There's a lot of this metal tape, this insulating tape It's pressed against a ground cable. A ground cable comes off the chassis and mates against this under pressure. Also here as well from the bottom one, this piece of wood was lifted up out from these nails on the bottom here. You can see how they're bent in and around. So what I'm going to do is I'm going to press these back into their original position. And then when they're in the original position, these screws go all the way through the case and also become the feet. We'll square that back off. Run this grounding strip that you can see here. Here's a piece of this grounding strip back to the chassis again and tie it off. But this chassis is now cleaned out. There's no more electronics in here except for the speaker. It's part of my quest to find out how this amplifier is built. By taking it apart, I can dissect it and see what kind of circuit is going on here, get an idea of how exactly this thing is assembled, as I have no schematic. Originally, when I did my first inspection of this amplifier, I thought this upside down 12AX7 that we saw from the top of the amplifier was in support of the vibrato, right? So this is not the case. This 12AX7 is actually splitting the two input channels, channel 1 and channel 2. And we can see the channels are here. There's like channel 1 or channel 2 or whatever it may be. And I find that as I look at the resistors, the channel 2 inputs are balanced. The channel 1 inputs are not balanced. They have a slightly different configuration on the second input of channel 1. So there's something going on there. Maybe perhaps that's a guitar microphone combination that may be in play. Regardless of what's going on there, maybe it's a different pickup combination. Look at all the efforts that have gone into this, right? So this sort of phenolic board that this circuit sits on has got these rubber dampeners. You can see these rubber shock absorbers. The board floats on this unit right here. It's isolated from ground. You can see it's got a springy bounce to it. As I push it, you can see the whole thing floats, right? And as we are now able to look at the tube socket, we see that this tube socket also has a shield on it, and you can see how this is important. Any hum that would be injected so early in this stage would work its way through all the stages of the amplifier, completely destroy the signal. So this was very safeguarded against microphonics, against any sorts of noise that would be picked up. The heater voltages are all pressed away from it, very far away. Any other cables are pushed away to make sure that none of this happens. I'm going to go through and check these resistors. Of course, these capacitors generally last forever. These ones right here, which in most applications are very microphonic, but these applications are fine for these are probably for watt treble, stuff like that. Yeah, these are pass filters. Right, these capacitors are I'm probably going to have to go. Those are kind of garbage, and these down here as well. So this whole thing's going to have to be disassembled. I'll be very careful with that rubber to keep the initial rubber. It still seems supple if you don't stress it. Just give a little, take it out, put it back in. Be very nice. I need to get this board done. Get the components analyzed for this board because I have to match components for the other board that I've been through, because one doesn't work without the other. And this stands to reason, right? Because we have signals going in and out and back and forth. So everything that happens has to come through, and that's why they use this shielded coax to get the signals back down after they're processed and go through the different things, and they have to work their way back up as well again. So that's what this connection is for. Okay, so we're starting to see what's going on here. We have this connection. It uses an octal tube socket to bring those connections up. But as far as the signaling goes, the signal path that's drawn up is done through a shielded cable that we see a connection on the other side. I don't have them both up at the same time here, but we will be able to actually set this amplifier up on the table running with both of these pieces hooked together without being in the chassis to an 8 ohm dummy load. So this will be pretty cool when we get this set up. But most importantly, this right here is just splitting the two channels, obviously changing from a voltage driven to current driven and splitting it out. One 12AX7 turns into two channels. The second 12AX7 on the other side of this amplifier is a phase inverter. This is going to be this is obviously a push-pull amplifier. Now that I've got the other side off, it's down here, but the 6V6 is driven as a push-pull. So that answers that question. And the 6AU6, that other tube is actually for the what is it, the tremolo. Is it tremolo? Yes, no, vibrato, whatever they call it. So that's what that configuration is. You know, I never had both of them up on here yet at the same time. But the tubes are out right now. I haven't tested them yet, but we know what all the tubes do. I have a basic idea of the circuitry at this point. So basically what I did is I worked from the inputs inward. I worked from the outputs, you know, this output transformer backwards to try and find out, you know, what the hell's going on with this thing. And I think I got it. So like I said, this is splitting the channels, you know, start to go through all these things with the, you know, the treble and the bass and what have you, and whatever it is we're doing. On this side, once that signal makes its way down, before it gets amplified, it goes through the preamp, this phase inverter. It gets split, and then it goes to these 6v6s, and then this is a separate circuit that provides that other thing that we discussed, that tremolo, the vibrato, and then these are the output tubes. This is the rectifier, and this is not a tube. This is that socket that, you know, connects the bottom of the amp to the top of the amp, and then there's a dedicated line, like I said, right here for the actual signal that rides separately that goes to there. So that's as much as I've discovered right now. The grill cloth on this particular amplifier is so fragile that once I remove the components that I need to, I take away the rest of the amp. I put the cover back on and move it out of the way. What I've removed is the lower portion that we've looked at before. Now having a look under it, it's not Fender or Gibson, so we don't have to concern ourselves with people who may be wanting to spend $70 on a capacitor so they could show their friends what a $70 capacitor looks like. However, I'm seeing a lot of dry type electrolytics right here. Even not having a schematic, you could look in these amps and identify a lot of components and coupling capacitors and what have you. We're going to have to go through here. We have no schematic to work on, so we're going to have to be smart about this and identify what's what, test out the components, replace as necessary, and restore this to working quality. This is really the lowest common denominator of point-to-point electronics. I mean, no, any expense that could be spared was spared with this one. You know, you have components that are literally used as ledge to support other components, right? So this is probably a voltage dropping resistor for the B+ circuit, going from one tube to another to drop that plate voltage. I imagine. I have no schematic yet, but I'll make that assumption. You can imagine that this thing must get so hot and sit there, you know, because this is the bottom of the unit. So this sits here roasting right under this chemically treated electrolytic capacitor for all these years, just heating that thing up. So we're definitely going to have to find a different solution. Probably the new capacitor will sit along here, and this will sit up in the tray somewhere, and so the capacitor won't be affected by the heat of that resistor right there. I'll look out for other resistors, other voltage dropping resistors like that, to ensure that that doesn't happen again either. Just for fun, to give me an idea how the dry caps were doing, the electrolytics, I got this 50 right here. It's reading 75 or 76. When I measured it on this, you could see that the bar, you know, the higher you get, the closer it goes, and it's reading that line past 50, and that could conceivably be in the 70s or low 80s. So that looks about right for this machine as well. The other disappointing or expected readout was the fact that at 3 volts, we were showing significant DC leakage, even set at mini lytic. Forget about the microamps. We were reading like 100 microamps of leakage, and this is rated for 25 volts DC, and it was crap at 3 volts DC. So obviously, right off the bat, the first component we tested is no good. I'm sure we'll be seeing a lot of that. I went and traced it through the circuit to find one of these aqua colored capacitors that was not electrically connected to anything else, you know, with the tubes removed, having everything removed. I did come across this one. This is electrically open from the circuit as it stands. The capacitance was good. It was like 0.013. However, unfortunately, as I look on my strictest measurement, and I do go with my strictest measurement where I can, we're barely making 50 volts. So 50 volts is the cutoff. These are rated to 600. So if you think about it, yeah, you're using your strictest measurement. Yeah, but my strictest measurement is dying at 50 volts. So, I mean, if I were to go with a more lenient measurement, would I make it to 100? And so I see what it does. And even if I multiplied by 2 and said, okay, we'll go with mini lytic, but we'll say it's 2, then it's like good for 100, maybe 150. These are rated to 600, so I'm going to say that one in particular would be no good. I'm going to go through them, but that right there is a telltale sign that these aqua colored Sangamo, these are, what are they, Sangamo capacitors, did not stand the test of time. So that's what we're looking at. Lo and behold, I was able to get a hold of a schematic for a different model amplifier. This is not for this amplifier. This is for a 275 Model F. However, this is about as close as it gets. This one has a reverb circuit. The reverb circuit uses a 6C G7. There are a lot of differences in just about every value as you start going through here. But what it does have, most importantly, giving me the power supply circuit, a lot of stuff is the same. Some filter cap differences, but this lets me know what I could expect. I could compute the differences with the resistance, the voltage dropping resistors, and get an idea what kind of voltages I could expect. This is really good because it tells me what kind of voltages I could see on the plates. And if it tells me what kind of voltages I could see on the plates, it tells me the voltages I could expect the capacitors to have to work with. And I'm looking at 130, tolerance sit around 150. And I come up to my board here. This is this 12AX7 circuit, this isolated board. I come up here and look at these Sangamo capacitors. This is rated for 600 volts. But I had the occasion now, as it's removed, to get it up here on the trusty IT11. And for those asking, yes, this is calibrated. I calibrate these more often than I need to. It is Heathkit. It does go back to the 50s. They are somewhat older, you know. So when I have nothing on the bench, I like to make sure that my Heathkit stuff is operating correctly. So when I do use my Heathkit stuff, my decade resistance boxes, my decade condenser boxes, which is very useful in circuit on these pieces of equipment, especially when you're adjusting biases and what have you, different applications on these tubes. You know, I could open up a particular resistor or capacitor, knock one of those boxes on there, do a mathematical calculation on paper and dial it up right in there and check the output on the hand tack. But sticking with the story, I digress. So we go and we check the leakage here at 3 volts. At 3 volts, it looks good. You know, we turn it up, 6, 10. We get up to 25. 25 is already slowing down. 50, you'll watch 50, it'll break open ever so slowly. You know, and there's 50. And then we get to 100. You know, these are not electrolytic capacitors, right? So we're in the paper and mica category. These are not mini lytics either, right? So we do hold it down to a couple of microamps of leakage. This is 100, this is dead, you know. This is not doing it. We look at the schematic diagram here. We can expect to see, given 117 volts of line voltage, you know, maybe 115 volts in 1960s. On this schematic, 130 volts. Probably a little bit more of a voltage drop. There's a little bit more in play here, but then that might have been compensated for in the voltage dropping resistors. You know, I haven't done a side-by-side comparison of everything here yet, but so I say 150. maybe, you know. Is dead at 100. I'm officially declaring all these crap. And another thing about this worth pointing out is that all these components really are crap. It seems like a well-engineered amplifier. It's sort of an enigma, this Danelectro. Well-engineered, a lot of stuff thought out in this, but the components are shit, right? I haven't seen any like really good components in this thing. The capacitors aren't anything to write home about, right? Nothing special. Nothing terribly wrong with the pots, but you know, not the kind of stuff I find in Fender or Gibson, you know. I can't speak on the ceramics per se. Interesting looking capacitors here. Look at those. Those look like 0.0022s right there. Look almost like resistors. Kind of funny, you know. But yeah, I mean, these are like, I'm not finding like Astrons, you know, these like planet like caps, and I don't know. This one looks like the stuff I find in old like international ham radios, like it from the 1940s, you know. So the money went into the engineering and the features, but it definitely did not go into the components. So the other thing worth noting, while I got you all here, all the resistors. And the resistors are quite shitty, you know. And I noticed this in some lower end products, and you see it here. And one of the things you notice, besides obviously the readings, you know, which are evident, is the fact that when you look at the resistors, and I've always found this sort of somewhat disparaging difference in quality, but you see how it's painted on, somewhat crappy, somewhat irregular, almost like it was like done by hand back then. Seems like a low quality job, like they're one off, and they're all original. But when I see stuff like that, you know, like they were hand painted color codes on there, not done by any like machine process or with a lower quality machine, you know, they seem to suffer in quality. So that seems to be the theme of this. Well engineered, you know, and the cost savings was done at the component level. So, but we've seemed to have untangled all of the mysteries associated with this device, and start getting all the supplies that I need to put this together, and we'll go from there. Of course, when testing an amplifier, no testing is complete without going through all of the tubes. We'll be using our trusty Sentry Fast Check tube tester, made in Mineola, New York. A gift from my Uncle Kenny. Thanks, Uncle Kenny. Well, that was a long time ago. But we'll start with our 6v6s and see what we got. This one's off the charts. We'll just move them on. The other 6v6 will live to see another amp. This 12AX7 shows a little bit weak emission, but it's a Sovtech, so nobody really cares, first of all. Second of all, if you were looking for a slightly subdued input without swapping out tubes, that may actually be a good choice. We'll save that. You know, we can always swap out. It's just a 12AX7, nothing special, but worth noting. Moving on. This 12AX7 also shows a slightly weak emission. Still good, just slightly weak. This did arrive with a slight chip on the tip there. Obviously did not break the vacuum. The tube still works. There is no marking on this whatsoever. This was established by pinout that this is in fact a 12AX7. Just whatever, somebody tried to clean it and rubbed off all the markings on the tube, but a little weak, acceptable. Moving on. This little 6AU6A, this controls the, this is part of the vibrato circuit. This one is off the charts, very strong. First thing you notice about this little tube here is it's got an internal shield inside the tube. Not much to see in there. You can see a little pilot. But yeah, this tube is good. Last but not least, we're going to go and take a look at the rectifier. Rectifier is an original Sylvania, and it shows a strong emission. We will call that good. Obviously, we will test it in circuit and see what it produces without load, under load, all sorts of good stuff. Once we get those filter capacitors replaced, then it'll be safe to operate.